So, remember last episode when I said,
I know this will be a lot of pieces, but since this relatively small machine is being built from the remains of a much larger machine, I think I should have enough to do it.
It turns out I'm running out of white rods. So far, between the trusses and the floor, the machine has used over 5,000 white rods, and just finishing the rest of the superstructure as designed will need around 5,000 more. How many do I have left? Well, about this many, plus whatever is left in some of these unsorted bins. This is a problem. One thing I could do is stop obsessing over color coordination and mix in some of the silver and black rods. But even with those, I don't think I'd have nearly enough. So, unfortunately, I think the solution is going to have to be removing half of the white rod X's from the truss beams and replacing them with yellow rods. Then I can reuse the removed X's in building the rest of the superstructure. As mentioned in the last episode, X's on only two sides of the box truss is still reasonably strong. It's just not quite as strong as X's on all four sides. This means I'll have to be a bit more careful when it comes time to move the ball machine, and there may be a few repairs needed, but it should still work okay. So what's next? Building up the rest of the superstructure will involve constructing 4 large towers on the corners of the machine and 4 smaller half-size towers along the back wall. But before we get started on that, there's something else we have to take care of first. This giant spiral bowl is the single largest ball machine element I have ever built. It measures 5.5 feet in diameter, 3 feet high, and has over 10,000 pieces. The spiral bowl was initially conceived as a challenge from a coworker when I was building my warehouse ball machine back in 2015. He asked if I could build a Connect spiral bowl as large as the giant coin funnels you see at science museums. So I drew a few quick sketches and then got started building. The framework came together very quickly, being made of simple box trusses, but the 4 concentric structural rings that support the shape of the bowl were a much greater challenge. A lot of trial and error was involved in creating rigid Connect structures of the exact radii needed for each level. Once the rings were completed, a mesh of angled rods and track connectors was constructed, and 250 feet of coaster tubing was added to finish off the bowl. This element was immediately popular, so when the warehouse machine was torn down and rebuilt into the ball machine at the works in 2018, I knew I wanted to keep the spiral bowl intact. The only problem was, how do you move it? I never built it with the intention of having it be moved, and if you were to pick it up from the edges, it would immediately collapse under its own weight. To solve this, I built a temporary 8-armed brace that sat on top of the spiral bowl to make the structure more rigid. In this form, it can be safely carried by just 2 people. So why am I bringing this up? Because the spiral bowl is currently sitting in the old lobby of the Works Museum, and it needs to be moved into the new lobby. And that means reconstructing the old brace needed to move the spiral bowl. Conveniently, the temporary brace for the spiral bowl is the exact same box truss design as the trusses used in the new ball machine. This means I will be able to repurpose the 8 arms of the spiral bowl frame to build the 4 corner towers of the new machine's superstructure after the spiral has been moved. So with the temporary brace finished, it's time to head off to the Works Museum, where myself and a few friends will move the spiral bowl to its new home. The spiral bowl was in pretty bad shape, so repairs had to be made before the brace could be attached. Once everything was put back in place and the brace was attached, the spiral bowl was ready to move. There's only one door between the old and new lobby, and it's too small for the spiral bowl to fit, so we had to bring it outside and carry it all the way around the building. Since the spiral bowl is nearly 8 years old, we also took this opportunity to blow some of the dust off of it. We then carefully brought it inside the new lobby and moved it to its final location in the museum, where it will sit until we move the finished ball machine and finally connect them together. With the spiral bowl in place, the temporary brace can be removed and brought home, where we can begin turning it into the 4 corner towers. Some amount of modification is needed for this part, since the towers will need connection points for the protective mesh cage that will surround the sides and back of the ball machine, but it still saves a lot of time not having to build them up from scratch again. Using the white X's salvaged from the base of the machine, we can also construct the 4 half-size towers that will support the back of the ball machine. We'll also build up the mesh walls that will help keep the balls from falling out of the machine. One of the requirements the Works gave me for this project was that it has to be at least partially visible through the windows of the museum as guests walk up to the main entrance. So to allow maximum visibility while also keeping the balls safely within the machine, I'm using the same mesh design I used for the Plinko board found on the previous ball machine at the Works. It's reasonably durable, easy to see through, and also very piece efficient. With the framework of the machine now basically finished, it's time to get started on the fun part. I'm going to build a prototype chain lift, so I'll have a way to test the ball machine once I start building the various paths and elements. This lift design is likely not final. I'll probably be swapping out the Connects motor for a geared DC motor and a 3D printed housing later, similar to what I did in the last machine, but this will be enough to start testing. I'm trying to make the lift assembly as narrow as possible since 3 of them will eventually need to sit side by side. To do this, I'm putting the motor in line with the lift, connected by a MicroConnects chain drive. Also, rather than driving the lift sprocket directly, I'm driving it using a pair of small gray gears which are held onto the axle by friction rather than tan locking clips. The idea here is that these gears can slip if the chain lift ever gets caught, rather than breaking the chain or snapping the tan clips off. I installed the drive and connected the chain with a Ball Factory style chain hook and turned on the motor. And it immediately jammed at the bottom. Looking at the problem in slow motion, it looks like there's just too much slack in the chain. Taking yet another trick from the Big Ball Factory's playbook, I'll add a tensioner gear that uses the natural springiness of the Connects rods to keep the tension on the chain. And now it works perfectly. I'll add a bunch more chain hooks for some more thorough testing, then we can run the lift for a while and make sure it's working smoothly. After running the machine for a few hours non-stop, it didn't jam once, so this should be good enough for testing the machine for sure. The last thing we'll do for now is finish off the framework with a large crossbar over the top of the machine. This crossbar design is 50% thicker than the standard box trusses to allow it to span the 7-foot gap with minimal deflection. I also decided to rebuild the 2 front towers in the same style for added rigidity. Now the overall look of the ball machine is complete. In the next episode, we'll work on finishing the lift design and start filling the empty space with ball tracks. Stay tuned, and thanks for watching.